Hello everyone, in this video we're going to discuss about the acceleration displacement graph and the main characteristics of simple harmonic motion. In the previous video, we have already created this diagram with the mass spring system having A, B, C, D, and E, and we have already gathered the information that this can be related to the relationship of acceleration and displacement. You can see here with the displacement versus the acceleration. In here, we say that if the displacement is at the positive side, then the acceleration is at the negative side. If this is at the negative side, then that means that this is at the positive side. With this, we can therefore conclude this relationship that acceleration is directly proportional to the negative of displacement. To further analyze this equation, we can have another formula, which is what we have discussed in topic 2. We have discussed that if we are using a spring, the magnitude of the tension force is equal to F is equal to negative kx. And this is also what we call the Hooke's law. Let's have a quick review onto this Hooke's law. We know that if the mass is at the right of the equilibrium position, we know that this is the net force, it's towards the left. We understand that because we already understand the meaning of the restoring force, which is always towards the equilibrium position. We can relate that to the formula, which is equal to F is equal to negative kx. So that means that if the mass is here at the positive direction, then that means that the net force or the tension force here is towards the left. If the mass is at the negative direction, then that means that the net force is towards the right. So we know that also another formula for force is equal to mass times acceleration. We already know this by the second law of motion. With this, we can relate this by ma is equal to negative kx, and a is equal to negative k over m times x. Therefore, we can conclude that a, acceleration, is indeed directly proportional to the negative of displacement. We can also have a graph for that. Let's say that a is the y and x is the x, and this is going to be our slope. We don't have the y-intercept. Maybe we have the y-intercept, but this is just equal to 0. So let's say that we can draw the graph for this. Again, the condition is for y, this is a, and for x, this is x. We're not going to have a graph like this because this is not a positive one. This negative indicates that this is here. So, sorry, this is not really so straight. This should be straight. So this is the reference for the graph relating to the acceleration displacement in the simple harmonic motion. This tells us that the acceleration has a direction which is opposite to and a magnitude that is proportional to the displacement from the equilibrium. So the oscillation will be simple harmonic. But what are the main characteristics of a simple harmonic motion? First, we know that there should be a fixed equilibrium position. There should be a fixed equilibrium position. And at the same time, another condition in order for you to say that this is equilibrium position is the formula that is relating acceleration to the negative of displacement. That when a particle is moved away from the equilibrium, something like this, moved away from the equilibrium, the acceleration of the particle is both proportional to the amount of displacement in the opposite of direction. This formula summarizes the whole situation for this simple harmonic motion. Also, there are main characteristics that we have to bear in mind whenever we're discussing simple harmonic motion. First, make sure that you know that number one, the period and the amplitude are constant. The period and the amplitude are constant. That means that this is not really changing. In that given oscillation, you're not considering to change or give force to it, because of course when you give force, you will also change the amplitude. Are constant. Next, the period is independent of the amplitude. Again, the period is independent of the amplitude. And the third one is the displacement, velocity, acceleration are sine, cosine functions of time. And if you will remember, we have already done this. We have this one, the cosine graph for the displacement time graph. We have the velocity time graph, which is the sine graph, and we have the cosine also, negative cosine of the acceleration time graph. That's it.